Today we're going to do part 1 of 2 for functions, because you need to write functions. Okay, functions increase the readability and maintainability of your code. What you do is you break it into pieces. Your prototype defines the function interface. You have a definition that provides the actual guts of the function and what it does. The prototype, its most important role is defining the types. And you use a function like any other expression on the right-hand side, and it will return a single value which will be used when you invoke the function. So functions it reduces redundancy. So you have some code that's used over and over and over and over again. So hey, let's put this into a function. So we'll just, instead of repeating it each time, you just call the function. And the function can do that code each time you call the function. This adds modularity. You can write your function and write it as independent of the rest of the application as possible. You have an independent module that can be moved and used elsewhere, either in the same application or some other application. It says, hey, we will use that. Adds readability. Anytime you can split things into pieces, the smaller the piece, the more readable it is. And of course, that means it's more maintainable. When it's easy to read, easy to understand, it's easy for somebody to fix or add features. And of course, reusability. You try to make your function, like I say, make it as independent of the application as possible, so you can pick it up and use it again in some other application. You don't reinvent the wheel again. It's round, it runs. Just grab the wheel that's working and put it on another automobile. So here's a quick example of some code that has no functions. So we're defining width, depth, and an easement. What we have here is a situation in real estate where you've got a street, and you divide the street into lots, and the depth of the lot is this direction, the width of each lot is this direction, and you have an easement for a sidewalk in the street, which takes up some portion of your real estate. When you buy the lot, you're buying the entire bit of lot, but because of the easement for the street, you can only use this portion of it. So the total area of what you're paying for is the width times the depth. The useful area is the width times the depth minus your easement. And so we print that out, total area and the useful area. And so you have one lot that you do this calculation for, another lot you do this calculation for, another lot you do this calculation for. We've already got a place where we might want to put this into a function. So here we put it into a function, and I haven't defined the function here. We're just calling it. So we're going to calculate the total area. We're passing in the width, and we're passing in the depth. When we get the useful area, we're passing in the width, the depth, and the easement. This will do its calculate. The function will do whatever calculations based on the parameters you passed in, and will return a value, which will be used in this expression. And in this particular case, it's printing the value out. Now, the prototype, your function prototype, has to come before the function is used. It consists of your return type, the name of the function, and some parameters, if any. So the type can be like int or bool or any of the user-defined types. You give it a unique name that's not a keyword, and generally a verb is a good name, like we want to calculate something, calculate area. And then you have 0 or more parameters. And the parameters is usually a type, very often with a name also. So calculate area will pass in int some side. So the int is their type. The name of this particular parameter is side. It turns out you don't need to give it a name for the parameter, but it's useful. It's self-documenting when you do that. And it must be defined before you refer to it. And a little quick thing on nomenclature. The parameters are what you call these guys that are being passed into the function. The argument is the value of a parameter. So if the side happens to be 5, this is the 5 is the argument. So here's an example of a prototype. We're returning a float. We want to calculate the useful area. We need the width passed in, we need the depth passed in, and these are each floats, and we need the easement passed in, which is also a float. And here we have a good example where each variable has a comment that says, this is what this parameter is for. So return type is float. The name of the function is calculate useful area. Then we've got our round parentheses, which include each of the 3 parameters that have to be passed into this function. Now, the definition of the function, that interface matches the prototype. So you've got the type of the function, the return type, the name of the function, each parameter that you're being used. And then you've got your curly braces for the code block, which is necessary. This is one place where you cannot have a single line of code. When you have a function definition, it must be inside curly braces. And your code that will operate on those parameters to calculate a result and return that value back to the caller. Now, you can put the definition ahead of where it's referenced, or you can put it behind its reference. Different people have different preferences for how they like to do it. Some people like to have their function, and then your main routine, whatever routines that call those functions. inside a function could call another function, which is ahead. That's fine. Or if you do that, then you don't need a prototype. Or other people prefer to have your main function at top, all the function it calls are below it. This function. If a function calls another function, that would be below it. But when you do that, you do need to have the prototype that defines how that function is called. It has to be used, put up there before it's referenced. So like I said, this is the definition is where you put the guts of the function, where the work gets done. So here's an example using our same function here. We're going to calculate the useful area, and we have our own definition inside this block. The useful area is equal to the width times the depth minus the easement. And then we return, here's a new keyword for you, we return that useful area to the caller. So instead of having this code repeated for each lot, all he has to do is call this function. Now you might look at this and say, well, that's only 2 lines of code. Well, obviously a function can have a lot more code in it than just 2 lines. Now, your types of your parameters, each function type has to be defined. All right, so this is the return type, integer. This is the function name, I just called it func. And you've got a count and a double. This should have been integer count. This is a mistake. So what we're doing is we're declaring that the first parameter is an int. The definition happens to be int of count, and the quantity is passed in as a double. And it does some calculations here and returns a casting to the int type of the count multiplied by the quantity divided by 2. And just a random arithmetic being used. So here I'm just illustrating that you did not need to say, you could say int func int count and then double quantity. But you don't need to do that. You can, in your prototype, you can just provide the type for each parameter. I prefer include the name. That gives you a little bit of self-documenting with the name of the variable, because most people know what a count is. And in your application, you're going to know what a quantity is versus a price versus an age versus a bunch of other things. So not just some random type of being double. So the documentation value, I think, is worth including the name in your prototype, but it's not necessary. Okay, when you use the function, you use it like any other variable. So here we have float useful area. And we're going to call this function called calculate useful area, and we're going to pass in these literal values. And it's going to do some arithmetic here. You could have just as easily said float useful area equals 17.9. So instead of 17.9, we're going to call this function and come up with whatever value it comes up with. It may not be 17.9. The arguments passed in can be literals, they can be variables, or the returns from other functions. So in other words, right here, we need to find out what is the easement in this particular jurisdiction. So we have a function called get easement. So we have standard width is a variable, happens to be equal to 50 in this case. 150 is the depth in this particular example, and then we're going to call get easement to find out what is the easement in this particular condition. Now, like I mentioned before, you must either prototype it or define it before you reference it, before you use it. The reference includes the parentheses even if there aren't any parameters. So you could define a parameter with you can define a function with no parameters. When you use it somewhere else, you include the parentheses with nothing in them. And whether you define them before or after, put all your functions up at the top, put all your functions at the bottom, it's up to you. Now, a function returns one value. There are occasions when that could be a pain because you need for a calculation to do something. And while it's calculating, it calculates something else that you also need. You would like to have 2 values returned. You can't do that. There are ways of getting around that, which we'll talk about later. But what you have is the function is used an expression instead of a value. So you have one value for each function. It's similar like a mathematical function. You say f equals sine of some number of degrees. It returns a single value. And there are ways of getting more than one result in your parameters, but we'll talk about that next time. And again, here we have some folks breaking their application into pieces. This is the red function, which is distinct from the green function, the blue function, and the yellow function, and they're going to put all these pieces together to make them work. And the smaller the pieces, the more pieces you have, the easier it is to manage things. And we'll manage more of this next time. Thank you for watching Educator.com.